everybody. Welcome to what I think is the final talk of the conference. I hope you've been having a great day at Data Science Connect. I know some of the talks have been so fun. I've been loving watching them. So I'm happy you're here and gonna walk through this last one with me. So this one is called, Are We Good Models? How does machine learning really work? And how does that model our own learning? So I'm going to talk a little bit, very big picture on kind of how machine learning models work and what they mean. And I'm going to ask for some participation from all of you. So I hope you'll jump in and answer some questions for me as we go through. So the first one is a little personal exercise, and this will come up later. I won't make you share it if you don't want to, but if you do want to share it in the chat, please do. So I want you to take a second, maybe a minute or two, and sit down and really think, what would make you feel successful? So you can pull out a notebook, Google Drive, Notes app, in a journal, or put it in the chat here, really wherever you want to stick it. But kind of think about how you would measure success and what you think you would need to achieve to feel successful, and really try and be as specific as possible, really measurable ways that you think would make you feel successful. And I will share my own later. So I'm going to give you maybe another 45 seconds, a minute, and you can walk through this. You can always finish it up later. So we have some more questions coming down the line too. So I hope you got a chance to find somewhere to keep all your answers for yourself at least. If not, share them with the rest of us. If you need a little inspiration, this could really be anything. It could be a job, a skill, a task, an accomplishment, whatever you think would make you feel successful, or whatever thing you would have to do to have that feeling. All right, I'm getting some good afternoons in the chat. Good afternoon, everybody. People from Texas. I'm in Seattle, so from all across the country. I hope you're all enjoying the conference. Okay, I'm going to move on to the next question. I hope you all had some time to think about this at the very least. So next question, would you have said the same thing 10 years ago? So, if you're a student, thinking back to 10 years ago can be a very long time. You were significantly younger. If you're an educator or a parent, thinking back to maybe your student days or 10 years ago, wherever you were, do you think your answers would have been the same? What do you think at the time would have made you feel successful? And again, we're trying to be specific. So, what goals do you think would have made you feel successful? What accomplishments? Was it getting a grade in a certain course, finishing certain courses, enrolling in certain courses, getting a certain job, whatever that means? What do you think will help you get there? And really looking kind of long-term, big picture on what you think this means. So again, this is looking back at your younger self and trying to think how you would have answered this question 10 years ago. Give it maybe another 30 seconds. If you're not writing it down, at least think it. I think it will be really applicable to the end of the talk and really show what we're trying to measure when we train some of these models. It's an interesting exercise. Cool. Give you another 10 seconds to think about it. Awesome. Okay, I'm going to hop over to the last question I'm going to make you sit down and think about and reflect on. But one, why did you pick those things? Why do you think those things will make you successful? Where did you originally hear that idea? Did someone tell you that idea? Did you, see someone else accomplishing those goals and it made you feel, oh, I think I could accomplish them too? And then lastly, what do you think made them change, or what made them stay the same? So if you thought back 10 years and those were completely different goals, what made you think about those goals versus the ones you have now? What made them stay the same? What made you realize, yes, these are the right things and I still believe they'll make me, feel successful and I still want to accomplish them? So again, I'm going to give you a little less time to think about this. You don't have to write anything big, but really just think about it for a minute. I know this is a lot of self-reflection we're starting off with, so I really appreciate you all sitting here and doing that. I think it's really important. Do another 10 seconds. Let me know if you need more time in the chat. All right, and let's get to maybe why you're here. So I'll do a brief introduction. I'm Morgan Cundiff. My pronouns are she, her. I am a data science manager at a company called LTK, where I am running our machine learning team. So we do a lot of different machine learning products, doing kind of all different kinds of predictive modeling work. All the opinions here I'm going to share are my own, but I've worked in a couple different e-commerce spaces doing various different types of machine learning projects. So I really tried to boil down what I think is important to understand about machine learning, whether or not you decide to go into it, but also a good foundation if you do decide you want to learn more about machine learning and data science in the future. So throughout the whole thing, please feel free to share questions in the chat, and I will kind of ask some questions. Hopefully we'll get some answers in the chat here. So yeah, let's move right along. Here were my answers. So when I did this exercise, I wanted to make sure I was doing it as well. So I thought back 10 years actually to when I was a high school student, going into college for the first time and trying to figure out what I wanted. And I said at the time, what did I think would make me feel successful, would make me feel fulfilled? And I went back and looked at my kind of plan when I was going into college, what I wanted to study, and really broke that down into things that I thought at the time would make me feel successful. So I really wanted to go into medicine. And so all my goals were really around that. So one, it was do well in my pre-med classes. I thought to feel successful, I want to be a good doctor. Step one there is really doing well in my pre-med classes. That would make me feel good. Next one was I wanted to intern at a hospital. I wanted to see what it was like being a doctor and really experience that. Next one was I wanted to get into a good med school. So that's kind of where all of this was leading. I thought, if I get into a good med school, you get a good job, you feel good about what you're doing, and you feel like you've accomplished a lot. And then lastly, all related, was I wanted a residency in California. So I really liked the California med schools. I really wanted to live in California. I thought, okay, this is my goal. I want a medical residency in California. As you may have noticed from the previous slide, I am not in medicine. I ended up becoming a data science manager, and I'm very happy with that decision. So we're going to talk about maybe how these measures of success changed for me down the line at the end of the presentation. And I hope you'll kind of do the same for your own answers. But to dig in, how is this actually related to data science and machine learning? Kind of the reason we're all here. So, how does a machine learning model really learn? And I promise that it will tie back to our answers at the end here. Okay, so first off, this is the kind of thing that a machine learning model might see. So say that we're trying to train a machine learning model to tell the difference between an apple and a banana. We might give it some data about apples and bananas. So, maybe it doesn't use these images, but we say, hey, we can tell you that this fruit is round, it's red, and it's about 3 days old. And so then the machine learning model might guess apple. And we said, yes, correct, this was an apple. Great job. And so then we give it another data point. We say, hey, this one's not round, it's actually long and it's yellow, but it is also 3 days old. Maybe our machine learning model, it says, hey, I was right last time and it was also 3 days old. Why not guess apple again? And so then it guesses apple again. We say, nope, actually this is a banana. And so it can update its importance. It can say maybe, okay, maybe this age thing here is not that important. I need to start learning what these other values are. And then we give it a final data point. Again, it guesses apple. It's correct. This was an apple, even though it's a different fruit than it saw the first time. So that's what we're really trying to do with machine learning. We're trying to say, hey, you've seen this previous data, you've learned from it. Now, when we show you new data, you'll be able to make an accurate guess about what this is. So I'm going to make you all be the model for me today. And try and guess something. So we're going to try and teach ourselves to be a machine learning model in a way, not machines, but teach ourselves how to tell the difference between these two different characters, the castaways and the bobs. So to start out, we're only going to get these 3 pieces of data. We get the shape, We get the color, and then we get the age, and we have to guess. So if you want to put in the chat, or you want to just think to yourself, do we think this is a castaway or a bob? I'll give you a couple seconds to think about it. Cool. And this ends up being a castaway. So whatever you thought, maybe you thought the color was going to determine it. Maybe you thought the shape. Now you can update and see, were you wrong? Were you right? How are you feeling based on this? All right, so let's go to the next one. Now we have a different shape, a different color, and a different age. So do we think this is a castaway or a bob? And this ended up being a bob. So different one. Now we can decide which one of these three, they were all different. Which one do we think is important? Let's go to another data point. Now we have a square, the same as the first one, and it's also red like the first one, and it's 6 months old. So the oldest one we've seen. I want to take a guess. And this one ends up being a castaway as well. So we are slowly learning what makes each one what it is. Okay, so now that we've, learned three, which pieces of information do we think is important in that decision making? We got the shape, we got the age, and we got the color. And now we're slowly learning which ones are important. So if we look at the data here, we see that the shape and the color are both different. So both our castaways here, they're both squares and they're both red. And, maybe the age, both the castaways are older than the one bob we have here. So that might also be important. So we're compensating all three of these factors into our guesses. Okay, perfect. So now we have one more. We know it's square, we know it's yellow, and it's 3 weeks old. So now this is a hard one because it's the same shape as two castaways, but the same color as the bob. So what do we think it is? Oh, I'm seeing some people send messages. Okay, good. It seems like we have guesses on both sides. And this one actually ends up being a bob, which might change how we are determining which one is which. So now we have a completely new one. Yep, we got some more guesses coming in here. Okay, so this is a new shape. It's a cube, but we know it's yellow, and we have seen yellow objects before, and it's 6 days old. So now which one do we think this is? Castaway or a bob? Hi, everybody in the chat. I'm getting, okay. So I think most people are correct. It ends up being a bob, and we can see now that it's because we've already seen these yellow ones. We've seen that everything that is yellow is a bob. And we've seen that the shape doesn't necessarily matter. We've seen squares that are castaways. We've seen squares that are bobs. So now we know that the color is most important. Yep. The guests are coming in. Great job, everyone. So that is, we are learning like a machine learning model of trying to decide which ones are more important. So now that we've gotten all this updated data, now which pieces of information do we think are more important? Right, the color and the age, because we've realized that the shape here doesn't actually help us determine which one is which, right? We're getting this information, and originally it seemed like all the castaways were squares and all the bobs were triangles, but then we had this one bob that was a square. So now we realize we're learning, yeah, great, yellow, great, yeah, exactly. So now we're learning that the color actually has a huge impact on which one it is, whereas the shape doesn't really have an impact. We can kind of ignore what shape it is and still get that label. So we've actually changed our information. We thought at the beginning both color and shape would be important. Now that we've had more data, we actually realize that color is the important part, and knowing whether it's red or yellow is really what's valuable. So even if we remove the color one here, can we tell the difference? We might be able to use the age and say, oh, it looks like the older ones that are months or older might be castaways, and the younger ones are bobs. So this is another thing we do in machine learning, is we can drop out a particular category and say, can we still make this prediction, or was that category the most important? So what if we add 2 new data points here just to make it even more complicated? So we're going to add a whole new color, purple. We have 2 different shapes and 2 different ages, and they're 2 different labels, bob and a castaway. So go ahead and put in the chat, why do you think one is a bob and one is a castaway? What might cause them to be the same color but different labels? Okay, cool. Yeah, I see people saying color and age. Yeah, so maybe what's happening is that we have to pay attention to two of these different categories at once and say, oh, maybe when they're, really young or new, it's purple, but then we see the castaways actually change color and become red. Whereas maybe bobs start out yellow and then as they get older, they change into purple. Yeah. So instead of just saying, oh, we just look at the color immediately and we know just from that one category, now we have to actually pay attention to how these two categories are interacting and say, is it a certain age? If it's below a certain age and purple, then we know it's a castaway. If it's above a certain age and still purple, we know it's a bob. So now we're seeing kind of more complicated interactions where we can't just rely on one category. We actually have to pay attention to how they relate. So the way we're going through and guessing these is actually exactly how most machine learning models work, is that we show them some data and they're playing around with what is most important. So really what they're learning here is which of these categories do we have to put importance on and how do they relate to each other? And then slowly make the decision of what label to get it. So let's go back to my answers at the very beginning. And I just want to say, I pulled out, all the things I said were my goals. So just a quick reminder, I want to do well in my pre-med courses. I wanted to intern at a hospital. And then I wanted to get into a good medical school and a residency in California. And then as I told you, I actually decided to kind of completely change my career and went into data science. So I decided that partway through college. And so that ended up really impacting how many of these I accomplished. So I want to go through them. So here I completed about 3/4 of my pre-med requirements before I decided, I don't really want to do the rest of these. I want to go into data science. I did intern at a hospital, but then I did not get into a good medical school. I didn't even end up going to medical school. And because of that, I didn't do a residency, definitely not one in California. So based on this, we might put these all together and say, okay, based on the limited data that we have, I wouldn't be feeling successful. And I think this just demonstrates just how important the choices that you make and how you evaluate both a model and your own life can affect things, right? Because I changed my mind. I now have a job that I love, and I do really feel successful doing it. And so I think just as we can evaluate our own selves based on these kind of preconceived notions of what we thought success was, this is also true of machine learning models, right? When we saw in that model, the more data we added, the better it was at guessing in the future, but also it placed importance on really different features, whether that was color, age, or shape. It really changed its mind the more data we added. And the more pieces of information we add here, like if we added something that said, have a job you like instead of getting residency in California, that would have been a 1. And then we would get a very different value here, just with the categories that we chose to show the model. So really what I'm trying to emphasize here is that in the categories, both that we choose to show models and that we choose to judge ourselves and the people around us, we actually are encoding our own bias. So the types of data that we choose to show a model hugely affect how it learns. And it's the same with us. We have to evaluate, why we want something, why we think something impacts the end decision, and then decide, should that go into a machine learning model? So if that's deciding our own goals, or if we're training a model and saying, hey, what kind of data do we want to share with this model? We have to say, why do we think that shape will be helpful in determining if something is a castaway or a bob? Should we be giving it to this model? And should we be allowing it to make the decision based on that category of data? So as I said, I hope this explains how the original activity kind of all ties back together, but then how it's important to be constantly reevaluating. And as we get more data, we say, are these categories still important? Is this what we still want to be making the decision off of? Or do we need to adjust? Do we need to add different categories? Do we need to remove some categories? Or do we just need more data to figure it out in general before we go using these things as fact? All right, so that brings us to the end, which I think is great because we are just at time. So If there's any questions, please feel free to put them in the chat and I'll try and answer them. If I don't get to them all, I did put my LinkedIn in here in case you have any questions about machine learning in general, or how I transitioned to get into the field. I would love to chat with all of you and answer these questions. So thank you so much for coming. I hope you loved the conference as a whole, and let me know if you have any questions.